This is section 4.2. We're going to be talking about systems of linear equations in 3 variables. In the last section, we talked about systems with 2 variables, and we had 3 different methods of solving them. We could graph them, which was great. It was our language, but it had definite limitations. We had the substitution method, and we had the elimination method. Now, theoretically, all 3 of these work again. But with 3 variables, we would have to graph in 3 dimensions. This still forms our language. We are still talking about lines that intersect in a single point. It's just, graphing in 3 dimensions is awfully hard to do on paper. So we'll be using the language of it, but we won't actually be trying that. And also the substitution method, although it does work, can get really ugly. So we're going to focus on the elimination method. These problems are definitely long, but they are not particularly difficult. I don't think you're going to have any trouble understanding every single step, but you definitely need to be careful and double check everything, particularly your signs. If you make one mistake, it can blow up on you, okay? I'm going to be giving you one method, one path through these problems. This is not the only path, okay? But this will keep you from working yourself in circles, which is also very easy to do, okay? I'm going to talk you through the steps here. This will be more for reference. You'll come back and refer to it when you come to a problem, okay? So the first thing we're going to do is, well, if you have 3 variables, you need 3 equations. So we're going to label our equations in order 1, 2, and 3. Then we're going to pair up 1 and 2, and we're going to eliminate any variable. So whatever looks easiest. And we're going to label this equation 4 after we add them together. So if we got rid of x, we'll now have an equation in y and z. Okay, we're going to need this, but we're not going to use it yet. Then we're going to pair up, see here we paired up 1 and 2, now we're going to pair up 2 and 3. And we have to eliminate the same variable. So if we got rid of x here, we're going to have to get rid of x here. And so when you're trying to decide what to get rid of, you might want to keep this in mind. X might be the easiest thing to get rid of at 1 and 2, but it might be a nightmare to get rid of with 2 and 3. So you may want to go with your second best choice here to avoid a nightmare here. It doesn't really matter. You'll get better with this. We're going to eliminate the same variable, and we're going to label this new equation 5. So if this one, we got rid of x here, we have yz here. If we get rid of x again, we're going to have yz here. So now we're going to have 2 equations containing the same 2 variables. And now we can solve it using what we did in 4.1, okay? Then we will know the value of either either y or z. Then we'll start back substituting until we get our answer that we write as an ordered triple, and it's always x, then y, then z. Okay, yes, I understand this may not have made a whole lot of sense, but let's start working a problem and see if we can make it better. I want to solve this system of equations. X plus 3y minus 6z equals 7. 2x minus y plus z is equal to 1. And x plus 2y plus 2z is equal to negative 1. Okay, so my first step, well, if you're working one of these and you don't have it written on a blank sheet like I do here, you're going to want to recopy it. I promise you, taking the extra seconds to double, maybe triple check that you have the thing written down correctly is worth your time. Like I said, these problems are long, and you don't want your mistake to be that you copied it wrong. That's incredibly frustrating. So I'm going to label these equations 1, 2, and 3. That way I can refer to them without recopying them every time, okay, which is an opportunity for a mistake. Okay. So now I want to pair up equations 1 and 2, okay? So far we have labeled our equations 1, 2, and 3. Now we're going to pair up 1 and 2 and eliminate any variable. If I pair up 1 and 2, the main reason I chose this as my example is that there's no one of these that is particularly easier than the other. Okay, so I pair up 1 and 2 and I eliminate any variable. But then I'm also going to need to pair up 2 and 3 and get rid of the same variable. I'm just making a choice here. Let's say we're going to get rid of y. And that was complete choice. Now, if I look at these two and I want to get rid of y, I have a 3 here, I have a negative 1 here. So if I multiply this entire second equation by a positive 3, that's going to give me a negative 3 here, and then when I add them together, it's going to cancel out. So my first equation stays the same. Again, make sure that you're copying it down correctly. Take those extra seconds to make sure. Okay, now multiply this entire thing by a 3. So that's going to give me 6x minus 3y plus 3z is equal to 3. Remember that one of the most common mistakes is to not multiply the constant side when you're supposed to. Every single thing needs to be multiplied by 3, and I'm double checking myself and it looks good. Now my y's cancel out. Add these together, I get 7z minus 3z is equal to 10. Okay. Now we have a new equation. We're going to need it, but not yet, and we're going to label it 4. So this is my equation number 4. We'll use it in a minute. Okay. Our next step is to pair up 2 and 3 and eliminate the same variable. Okay, so we got rid of y. We're going to need to get rid of y again. So I take 2 and 3, and let me draw in some arrows so you can see the order I'm going in. Okay, now I need to get rid of y again. Here I have a positive 2. I need a negative 2 here, so I'm going to multiply this by a positive 2. It's going to give me a negative 2 here, and they're going to cancel out. So multiply this entire equation by a positive 2 to get 4x minus 2y plus 2z is equal to 2. Okay, now recopy this one. Again, being super careful about copying everything down correctly. Okay, now the y's cancel out the way we want them to, and I get 5x plus 4z is equal to positive 1. Okay, so we've done this step. Now we're going to label that 5. So this is my equation number 5. Okay, next step. Pair up 4 and 5 and then eliminate either variable. Okay, so if I pair up 4 and 5, this is essentially a problem that we did in section 4.1. Okay, we have the same two variables, except that should be an x there. Sorry about that. That's the kind of thing we have to be super careful about. All right, now if we want to get rid of a variable here, if I take 4 and 5, well, only because this is a negative and this is a positive, that's the only reason I think z might be easier to get rid of. Now remember, when you don't have something that's easy to turn into something else, you're probably going to multiply both equations by something, and we kind of think of it like our least common denominator. If my denominators were 3 and 4, my LCD would be 12, so I'm going to turn these into versions of 12. To make a 12 here, I'd multiply this by a 4. To make a 12 here, I would multiply this by a 3. Now check your signs. I'm going to have a negative 12 here and a positive 12 here, so I don't need to change anything. Multiply this entire equation by a 4 to get 28x minus 12z is equal to 40. Now multiply this entire equation by a 3, and we get 15x plus 12z is equal to 3. Now add these together. Your z's cancel out, and we get 43x is equal to 43. Okay, and we can divide both sides by a 43. And we know that x is equal to 1. So now we have one of our 3 variables. Okay. So now we know one of the values of the variables. Now we're going to do back substitution into either equation 4 or 5. Now why 4 or 5? Because if I plug it in here, I know my x, but I still won't know my y or my z. Whereas if I plug it in here or here, if I know my x, I can find my z. So here I would be able to simplify. Here I'm able to find another answer. So just pick whichever one of these looks easier. I kind of like this one better. I don't know why. So I'm choosing to take this, and I usually draw a double arrow. I'm going to take this x, and I'm going to plug it in. I've chosen to plug it into equation number 5. So this is 5 times 1 plus 4z is equal to 1. So 5 plus 4z is equal to 1. If we subtract 5 from both sides, we get, sorry about that, we get 4z is equal to negative 4. Divide both sides by 4. And we know that z is equal to negative 1. Okay, now our last step here. We now know 2 variables. Now we're going to back substitute into 1, 2, or 3. And the reason we now have to go into 1, 2, or 3 is because these are the only equations that still have a y in them. Okay? So I know my x and my y, and it looks to me like maybe equation 2 is going to be the easiest to find my y value, because here and here I'd have to divide, and that's really the only reason. It's pretty easy on any of them. Okay, so I'm choosing to plug in x equal to 1 and z equal to negative 1. I'm going to plug this into equation number 2. Okay, so see if I can get all this on the screen. Okay, equation 2 would be 2 times x, which is 1, minus y, plus z, which is negative 1, and this needs to equal 1. Okay, so I have 2 minus y minus 1 is equal to 1. Combine like terms, and I get 1 minus y is equal to 1. If we subtract 1 from both sides, we get negative y equals 0, and then change the sign on each side, which is y equal to 0. So now finally, our last step, we know x, y, and z. We write our answers in ordered triple. So this is the ordered triple: 1, 0, negative 1. This is a point in 3-dimensional space. If we could graph these 3 lines, this is the precise point where they would cross. To check this, it needs to work in all 3 equations. You plug in 1 for x, 0 for y, negative 1 for z, and it should check out in each of them. Okay? Now, the majority of your problems are going to work precisely like this. Okay? So I'm not going to work a bunch of these. You can follow this order and it will work out pretty much the same way every single time. There are some where things deviate a little bit. If you can understand the why we did every one of these steps, it will help you out in the other. So let me talk about that just a second. The reason we paired up 1 and 2 and then 2 and 3 is so we could end up with 2 equations with the same 2 variables. That way we can apply what we learned in 4.1. That is why we pair up 1 and 2 and then 2 and 3. We're reducing it to a problem we already know how to solve. So keep that in mind.